Hello, welcome. I thought the first lesson we should do for this distance learning would be how soap works. So I've drawn here a typical soap molecule, sodium laurite. This sodium ion is attached to this portion of the soap molecule. The reason the soap molecule is so unique is that it's both polar and non-polar. This side's the polar head, this has the polar side, and this is non-polar. Instead of drawing soap molecules like this, we typically just draw them like this. And this is the polar head, or we would say it's hydrophilic, loves water. And then this portion here would be the non-polar tail, and it's of course hydrophobic. So for my AP Chem kids, I want you to understand a couple things we'll be learning. This oxygen atom is more electronegative than carbon, so there's a dipole in this direction, and that makes this oxygen partially negative. This oxygen is kind of interesting. Follows the octet, and if we look at what's called the formal charge on this oxygen, it turns out to be -1. And so this oxygen has a -1 charge. The way you can determine formal charge is you look at the number of valence electrons the atom usually has. Oxygen has 6, minus the number of bonds in the molecule, so there's 1, plus the number of dots. So let me just erase these dot lines here and put in the dots, so that's 6. So you can see 6 minus 7 is -1. That's the formal charge on the oxygen. Okay, so let's get back to the soap molecule. We said it's both polar and non-polar. We say that's an emulsifying agent. And we all know soap does a really good job of getting dirt and grease off of our hands and pans we put in the dishwasher. And the way it does that is, if this is a little glob of grease and fats are non-polar, and what will happen is the soap molecules will surround the grease like this. The non-polar tail will attach to the grease, the dirt or the grease, the non-polar substance. And then what will happen is, by the way, this will be 3-dimensional. This is called a micelle. And then what will happen is water molecules will attach like this, and then the water will just take away those micelles off your hand and down the drain. Of course, we know that hydrogen is partially positive. This is a -1 charge, so there's a dipole attraction there, another intermolecular force. In the case of this virus has a lipid, a non-polar membrane, and then as you've seen lots of pictures of these viruses, there are these protein spikes that stick out from the non-polar membrane. And these protein spikes are they're the way they can get I think it's the RNA into cells. These can kind of unlock your cells and convert and get the RNA to go in your cells. But what soap will do is the soap will actually kind of pry open this membrane. So we have these soap molecules, and it'll actually destroy the virus. So keep washing your hands. All right, I hope you enjoyed this first video, and I'll give you an article to read that I found in the New York Times concerning this, and also have you watch a clip on an astronaut that flew candy corn in space on the International Space Station. It's a nice analogy to a mycel. So I hope you enjoy that. I'll see you later.